Hello, everyone, and welcome to today's call. This is Kenya Data Platform User Group. So we have been having this series for backend development with Node. Specifically, we are using Nest.js, which is a Node.js framework, and we have been tackling different topics. So just in case you want to catch up with everything, you can always RSVP our in an event in our user page. So for example, if you come to Kenya Data Platform, you'll always see the events part. So in the events, you can see the upcoming and the past events. And these are the upcoming events, and you can always come here and see the past events. So just in case you missed a past event, for example, this one, you can always come here and you can see the links to everything. So this is the link to the YouTube page where we are uploading these recordings after the call. And you can always see a link to the GitHub where the workshop code and all the materials you need to work on or clone or play with will be uploaded there. So every event will have these two links. So yeah, that's the simplest way to get access to that. So for the next course, you can always go to, as I have showed you, to the upcoming ones and just go there and click on them and make sure that you have this green check saying going after you RSVP. That will make me know that you're coming, and also other people will know that you're coming. So that's it for the introduction. I think we can jump on to work on. So today we are going to continue with our discussion, and the cool part is that we are going to discuss more on API caching. That is our topic. So let's jump on into it. So my name is Kevin. I'm a software engineer at Griffin's Global Tech. I'm also a Microsoft MVP on web development at Cosmos DB. So what you're going to cover today is caching, and specifically caching strategies, which you can use them in different parts of your API. As you can see, we're using Nest, Drizzle, Postgres, and today we're going to introduce Redis. So Redis is a caching database. It's more than that these days, but it is heavily used as a caching database. Okay. So when I talk about Redis, so if you're new to any caching database, Redis usually use a memory, that is the RAM. So if you're using your Redis via Docker in your computer, Redis will be stored. It will store its data in your RAM. Okay. So if you're using Redis in cloud like Azure, Redis will be using, in Azure we have compute, we have RAMs, we have SSDs, and I think these days they don't use hard disk, it's just SSD, but I think also hard disk is used. So when you provision a Redis instance in Azure, it will be using the RAM in that instance. So it is way faster. This is just basically computers and computer science. When you're accessing something from RAM, it's way faster than when you're accessing something from your storage device. This can be a hard disk or a solid state device or SSD. Other than that, the other things we have been using are the same: Docker. We have Zod for validation, Drizzle as our ORM, Postgres, and also Nest. Okay, so cool. These are the things we'll need as I have discussed them. briefly. We're also using Node and BNPM. Um, why API caching? So sometimes you might find that when you're working in your local host, everything is way fast because there's no latency between one service to the other. So when you start working with, let's say, a Postgres instance deployed on Azure, let's say you have Azure DB for Postgres, um, Azure Postgres DB in Azure, sorry, and you have your app service where you have deployed your Node.js API. You find that those things, even if they are in the same region, um, there is that latency between them talking. And sometimes that can go to milliseconds all the way to seconds or minutes. So sometimes you might find that you need to optimize your API so that it can be faster. So that is one reason. The other reason is when you have a database in Azure or AWS or Google Cloud, you find that it is quite expensive still because some of these databases have models for paying, and these models sometimes may be within um, the number of writes and reads. So you might save that traffic which is going on every time into your API to your database and share that traffic to your Redis cache database. So if you have Redis, you'll know that your Nest.js API will have fewer latency. You will have fewer DB queries. You will also have like high number of cache hits, which I'll talk about what is a hit. And then overall, the API response will be fast. Some of the strategies we are going to talk about today is cache aside read pattern. This is basically where, let's say you're using a postman or you're using your front end as a client, and then you send a HTTP request to your controller. That controller will send the request to your service, which interacts with the database. So the cache assist read pattern makes sure that before the service queries data from the Postgres, it is first fetching or checking whether there is cache that exists in Redis. So this saves more minutes because um, the trip to Postgres, as I've said, takes more time than to the Redis because of the underlying technology of using RAM versus using um, a hard disk or an SSD behind the scene. So let's speak about another strategy. And just in case you're new to this or this is a little bit confusing, I would like you to just hang around until things start clicking in. I think we shall discuss more of these into details. But basically, just know we're going to use I don't know how to pronounce this. It's KV, K, cave. It's pronounced as cave. Cave is it's a library which is now like being standardized the same way we were talking about Zod with schemas. KV is like a standardized library which is used for caching. So it connects to different databases which can support caching. Redis is one of them. So we shall be using that, which is a cool way of doing it. So as you can see here, we are pulling in Nest cache manager. And then from that, basically, we're also pulling in KAV stroke Redis because as I say, it supports different databases. Redis is one of them. And then using this, we shall create things like a store, which we're going to use. These are some of the 7 caching strategies you can use. Some of them are a little bit complex. Some of them are way easy. Sometimes we combine two of them or three, but in either way, if you know how to use one, you can just use the other. So the first one is Redis backed distributed cache. So this basically we're using cache manager, Redis as usual. And the cool thing with this is it survives restarts and it scales consistently. So this is like a general pattern where you have Redis, you're using it to help the API to be distributed. Okay. So even when the API restarts, let's say you have a new deployment that will, of course, when you push code to production, it will make the API to restart. In such a scenario, the Redis will make sure that it is still retains the data which was cached. So when the API restarts, it will still meet the cache there for it. As far as the time to leave, it has not expired. We also have cache aside for it. Basically, as the name goes, we use this when we are fetching data from database. So before we fetch from database, we fetch from Redis, and if it doesn't exist, we go to the database. We also have per endpoint details. So these are pattern where, let's say you have a get request, you have a fetch, you have a query request, you have an update request. Um, you have a delete request. So all these requests, you can have different types of caching pattern. So this is what we call per endpoint TTLs. So all those methods will be to a specific endpoint. That is one endpoint. So basically, when you set cache for that, in Nest, it will be a class with different CRUD methods. So if you set your caching pattern on the whole class, that will apply to everything. So we also have query aware cache keys. So this is tricky. Why am I saying it's tricky? It's because if you just set a caching on a method that is just fetching a lot of data and it has sorting, filtering, it won't work. So the best way to go is through this query aware cache keys pattern, which will create a cache depending on the parameters on the URL. That is, be it sorting parameters, be it filtering parameters. So when those parameters change, a different cache is stored. So it is way smooth. Yeah. We also have versioned cache um, keys. This one is where we have like a version 1 of the cache, version 2, and every time we create a version, the older version expires. So this is also a cool way of doing things. Targeted detail invalidation, and the other one more into specific areas. For example, targeted detail invalidation. It deals with even if you're using something like Dunstar query, you might handle invalidation. Okay, so this mostly deals with the, the request which we are sending to our API that is going to change the data. So think of this as an update request, a delete request, and probably an insert request. Those are the requests which are going to change the already available data. Okay. So now that we have explained that, I can just show you a small instance of the version collection pattern, which we were talking about here on step number 5. So this combines that and invalidating the queries, as I said. So let's say you have your first request. So your first request will do something like get all the employees. And remember, I'm assuming that you guys know that we are paginating our data, limiting that so that you can fetch like the first 10 records or the first 20 records, and then even you can sort them with name or whichever field you like. So in this instance, when you fetch the data the first time, this is what will be cached. We'll have like a cache version 1. And then after write, let's say we insert something, and then the data that was fetched, which was version 1, will be stale. So stale data is like outdated data. So, and then after that write, let's say we have inserted a new employee, a new cache will be created that is version 2 now, which is the current updated data. And then the version 1 will immediately be stale and Redis will get rid of it. So that is like the version collection keys pattern, which can involve different other patterns. We also have query aware cache keys. So like I was saying, if I'm getting employees where page is 1 and limit is 10, that will create a cache entry known as employee list v3 page 1 dash limit 10. If I change that query and make it now page 2 and limit 10, that should also create a new isolated cache entry in our Redis database. So every time there is a change in these parameters, it should create a different cache. So that's it for that. So as I was saying, this is the other pattern which we are talking about, invalidation. How does it happen? Let's say you have an update statement in your Postgres. It is going to insert, it's going to update the data which already exists. So what will happen in that request is that a delete detail key will happen. So we are going to delete the already existing cache entry in our Redis. And then we are going to increment the version. Remember, it was version 0 or it was version 1. We're going to take it to version 2. And this version 2 now has the new data, which we have already updated in the database. And now we have updated it in Redis. And then this is going to refresh the data in whatever request is going back to, and it will automatically create a Redis object, which is going to be returned with the original, with the new data now, with something like cache missed, which is correct. But if we run the same request again with the same parameters, that is set array to 95,000, where ID is 123, the cache miss should be not miss. It should be another, whether okay or cached, whichever name you want to make it there. It should not be miss. Okay. Other than this, why do we need Redis? We need it to improve the overall speed of our API, be it response time, be it the number of requests we're sending. Let's say we are sending 20 requests, 20 similar requests. These should just be fetched from the cache. So when we have a traffic spike, that is when we have a lot of traffic accessing one entity in our database, we need to reuse these and fetch it from the Redis cache. So how will these appear in our API response? So we'll have our normal object, that is the data object, with the data we want to fetch. Then we have metadata. The metadata is for storing the page type of data. This is page 1, the number of records in that page. And then we have the cache object. So this should store something like the strategy we are using, that can be cache aside, or the other strategies we have spoken about. The key, which is like the primary key in Redis that is going to uniquely identify this cached data. Time to leave, that is after 300 milliseconds, this cache is going to expire. And hit, so hit can be true or false, or sometimes you can say miss and hit, whichever. It's a Boolean value which is true or false. Okay, and then the timestamp. Time to leave, as I say, this is basically in milliseconds. So you can think of time to live based expiration strategy where you have like, hey, after you do a create, update, and delete request, you should have like cache time to live duration of like 5 minutes if you like. And then if you're just fetching one employee, one user uh, whose data is not going to expire unless it is updated, you can put that to 30 minutes. But if it is invalidated, like an update statement or a delete, it should be able to clean this TTF. So you also have list version, you can put it like this. So this is a way of thinking how you're going to architecture your API in a way that it is consistent in terms of caching based on the time to live strategy. So as we're going to see in our code base, these are the steps which you can follow to create a workshop and use it. So prerequisite of running this project, as I said, is PNPM, Node, Docker. You need to have Docker installed and Git. And these are some of the steps you can use to make sure that it's good. So let's do a live demo. Before that, I welcome any question before we do a live demo on what is happening. You can feel free to unmute your microphone or maybe under the QA, use the conversation where I've just sent a message there. You can reply with a question. After that, I think we can jump on to our demo. Just give me a second. Okay. So this is our third workshop. So everything is similar to what we have been doing in the past. So if I go to a new project, the first thing I usually do is to open the package.json to just know what is happening. And if you can just ignore the scripts first, you can see the new thing that we have added to our continuing series is that we have now a cache manager. We have cache manager, the next library one, and it's on the cache manager on its own. And then the next thing we have added is the KV. KV is what we're going to use to connect to Redis. Other than that, the other things are the same. PG is for Postgres. Yeah, we have Zod and we have Rizorem. So the next thing we check is in the composer. Docker Composer is where now we define the images we're going to use. So if you come here, you see we're using Redis. We're using Redis Alpine, which is the Linux version, which is way, way smaller than the Windows one. I know Michael is smiling now that I've said something cool about Linux. So other than that, the other things are the same. Like we have to execute these to run the server once the image is on. This is the name of the container. These are the ports. By default, it is usually 6379 for Redis. And we are testing whether the image is ready by pinging it for some few milliseconds with an interval of 5 seconds for 10 times. And then if it's not ready, we know it's not ready. And then we are going to stop. So This is the Redis. This is a new thing. The other things are the things we have been using. Postgres, the same things we have been using. We have our image here for Postgres. We have our container. We have our ports. We have our environmental variables, that is username, password, and DB. We have our volume to persist our data. We have our init database script, which is inside the Docker folder, inside the Postgres folder. And this is basically creating our database, two databases, by the way, one for development and one for production. Anyway, and then we have our health check. Good. These other things are just for creating our API's image. That is, if you want to Dockerize everything and have three images, that is one for the API, one for Postgres, and one for Redis. So cool. Other than that, we have a README file. And this README file has some of the things into details, some of the things we have discussed through. So it has these drawings, which are cool. You can always see what happens when I say like cache miss, cache read, those type of things, hit and miss. It's where instead of reading to the Postgres, we are hitting the cache. So if we hit it, we are reading from the Redis. If we miss it, then we go to read from the Postgres. So you shall see some of these patterns in an image, in a diagram type of way. So where we have the client, we are fetching all the data. This is going to the find all. We are having Zod to verify that. And then it is hitting the service where we have like 1, 2, 3 steps. The first one is to check whether we have this data stored in a cache. If it is there, we return it. If it is not there, so if it is there, we return it. If it is not there, we go to the Postgres. So cache hit is if that data is in the cache. If it is not there, we go to Postgres, fetch the data, return the data, and also update the Redis cache so that the next time we fetch it within a span of like 1 second or 2 seconds, we'll fetch it from Redis. So these are the patterns. I think this README will help you narrow down what is going on in almost everything. I've put a lot of effort on this to make sure that it is well understood, that it is something you can just use on your own and create one of the best APIs with cache. So starting today, you should be a Redis ninja or something like that. I don't know, warrior, soldier, whichever shows that you're good in Redis. And you should not fear when someone say, hey, I have 7 years of experience in creating APIs that are this and that. Those guys just know some few things like this, okay? And that's what we are doing in our user group. We just want to make sure that we build confidence in us young engineers in these topics. So when someone says microservice, when someone says Redis, you even go an extent to tell them, hey, I can just name 3 or 4 caching strategies and you sound way, way experienced, but unemployed. So that person will be ready to give you the next job. Anyway, let's dive into the code. So I have a new way of doing things. I'll just first show you a demo. And the cool thing is that we're using this extension known as can't even remember it, but it is client something. Let me just show REST client from MAO, watch MAO. We're using that because it is easy to create a file with everything you need to run or test your API. I've gone ahead to document the API well better than the previous ones, so that you can understand how caching really works. Like if you send your first request, probably that would be gotten from your Redis. It will go straight to the database. But if you hit the same request within a duration of like a span of 2 or 3 seconds, you are probably going to fetch that from your Redis. Okay. So with this, you should be able to go through everything of this and become, as I said, a nest ninja. Yep. It's something so useful. I think you guys are going to enjoy. Cool. Let's run our API. So the first thing you need is Docker. So I'm just going to spin up my Docker desktop. So this is Docker. That's all softwares in the world. Um, there it is. So as I can see, we have several projects, but these are just my own dummy projects. Cool. As you can see, nothing is running. Okay. So we need to spin up our API. If you go to package.json, you see everything. Um, I, I don't want to assume, but the way you do this, if you copy this code, I'm just going to go through everything. So the first thing is that we need a database. And we have our images here. We have our Docker with us. So if you have an extension known as, I think, Docker, okay, is it Docker? And I can't remember. Yeah, no, even it's not Docker. I think it's just if you have dev containers or if I think VS Code just have these. I think you don't need any extension to just have this run button, which is way cool if you're not a Docker expert, but you don't remember the commands. So I have my Docker running here, as you can see. So I'm just going to show you the easiest way to spin up our Docker. So I want to run Postgres and also Redis. So by just clicking run service, which is going to open a terminal on VS Code, it's going to spin up something here. As you can see, we have API caching strategy. And inside here, we have Redis, which is running. Okay. Let's now run Postgres. So if you have Postgres here, just click on this. It's going to open an instance for that. And now Postgres is running. And as you can see, Postgres is running on port 5432 inside and outside the Docker. And then 6373 Redis is running inside and outside. Okay. Other than that, we have our database and our Postgres running. We can minimize this like that. So now that we have that, the next thing you need to do is to make sure that you have your database running. So inside here, we have two commands you can run to know whether your database is up and running. So the first one is just to npm run db studio. So this will make sure that this will spin up Drizzle. Sorry, but make sure it is spins up Drizzle. And Drizzle is the ORM which we are using, which will just open this URL. And as you can see, we have past events we can see here. But for your case, probably you won't have this. So I'm just going to drop this. And now we have nothing. Okay. So for us to have a database, I'm just going to drop the migrations. So that should be inside. Inside the database, we have migrations. I'm just going to delete this. So if you're new, you need to do DB generate. So this is going to go to our schemas. For example, we have events. We have this event schema. We need to convert this schema into a table. And Drizzle knows that because in the Drizzle config, it's able to know where the schemas are. So they are inside where. And it is going to create a migration also. So let's just simply generate this. So this is pnpm run db generate. So this is going to pull something from our local.env. I'm just going to explain this shortly. We have our Redis. This is how the URL looks like if you're fetching from your Docker or your localhost. But if you're using Azure, it will look something like this. Redis. Obviously, we'll have HTTPS, Redis, username, password, then the host, and then some box, and then the DB name. That's how it will simply look in the cloud. So we have our normal connection to Postgres, and then we have these things which we are going to call. Actually, we shall talk about them later. So now we have our migration. So inside our database, we have our migration folder with this, which is the equivalence of just a table in SQL code. So we need now to push this into our database because, as I said, in our database, we have nothing. Okay, we have nothing. We don't have even a database. So how do we do that? So if we go back to the package.json, we have this next command, migrate, or you can just do push. So let's just do push. So I just go to my previous command and do that. So this is going to ask me some few things like, hey, do you want to override this, blah, blah, blah. I'm just going to say yes and apply those changes. So I believe now if I reload this page, we should have the events table with us, okay? And it has everything. Cool. Now that we have everything's synced up, we have our database running. The next thing we need to do is to seed some data, okay? And I have already done that for you. So we have a seed script, which is basically something to insert a lot of data into our database. And under the seed, we have the seed data, which is this dummy data. And then we have index.ts, which is basically using the events and then looping through them each by one, inserting it into our database via this connection, okay, which we are pulling in and we're using a pool, which is a better way of connecting to a database using a pool. And then simply we are just doing the inserts. Okay, we're inserting one record at a time. So let's do that. So pnpm run db full column seed, like that. I'm not sure whether that is the command, but I think so. So we have inserted 6 records. Cool. So if I just open this and refresh, we should have 6 records. So we have our data ready for us to use it. So let's say we want now to query the data, we need to run the API. So I just need to do pnpm run start dev, like that. So this is going to spin up our API. Now the API is running now in watch mode. So this is cool now because I can just open app.http and run some few commands. So let's go all the way to the top. We don't need to insert new data, but yeah, here we have the events. So clicking on this will list all the events. Okay, the first call. So what I expect is that I need to have an object there with the caches. So send this, we have all the data. And as you can see, we have these collapsible data object, and then we have our metadata. which is basically fetching everything because we have not provided any parameter for filtering or for pagination. But the good thing is that you can see we have time to live is 6,000. We have already cached our data. But for this request, our cache was missed. So we didn't hit it. So the hit is false because we fetched from the database and then we updated the cache. So if I fetch this again right now, okay, you see nothing changed, but the cache changed from hit from false to true. So we have fetched from the database. That is because, as you can see, even nothing is changing. It's that fast because we are fetching from Redis. How can we confirm whether we are fetching from Redis? So you can use the Redis app, but hey, it's 2026, we're using extensions. So we have this Redis extension from Redis themselves. We have like a million of them, so try to stick to the one from the Redis. So if you install this, you should see an icon on your VS Code looking like capital R. So if I click on this, I should be able to, for me, I've already connected. So if I just delete this, you should see something like this, which should ask you to connect, okay? Since you're using localhost and everything, this should just be the same. You're not using username and password. If you want to use this, make sure that when you're creating the image on your Docker Compose, it has username and password. For me, I didn't use this, so add Redis. I should have a connection to the Redis server, which should give me this type of folder structure. What is it? So it has this event API cache. That's the name of the store. And then we have like the events. So event is what we have fetched the request we sent. So it is still them. So what I like doing is to make sure that we have this auto refresh because it's something that is happening within milliseconds. You better like check out like how is this often happening. So I like doing these after like 2 seconds, refreshing these after 2 seconds. So if you have 2.0 there, um, like this and okay. Okay. So this is going to refresh after 2 seconds. Okay. Uh, so let's see. So I want to run my request and also see the cache. So let me hit the first one, send request, fetch everything, send it again. And here we should be able now to see, if I click on these, we should be able to see this page. Okay. So which again, I want to send this to 2 seconds like that. Auto refresh. Okay. So it's on this side. Send again, send again. As you can see now, we are actually fetching from that and it is refreshing and you can even get the data, the value that is being cached. There was a better way of seeing the actual data. This is intimidating a little bit. Yeah. Anyway, we shall get back to this. because what I can see is just a key. Anyway, we shall get back to this thing. But anyway, let me just close this first. Let me see. Okay. Let's go to 2 minutes. I'm not sure whether I know whether it is 2 minutes or seconds, but anyway, let me see. Oh, here is the data. Okay, cool. Now we have our data. So sorry, I think the time to leave here was 2 minutes instead of a second. So once you set time to leave, it is going to refresh everything you're fetching within like a second. And as you can see, this is the data. It's not well. A Unicode. Oh, here is a JSON. Cool, thank God. So we have our formatted data. So if I send new requests, even for these, okay, and let's say these, we should have all that data listed here with different uh, caching lists. So let me just close this so that you can see it better. So you can see the data which is being cached, and it's going to go away after milliseconds. So this one is inside Redis. Okay. Well, so time is running out. So as you can see, you can please go through this and get different data and also check what is changing here. And every time we create a new we run a new request, you see it is being cached, and it is being given a different key to do that. Even when we create a new event, it's going to invalidate the one of the existing requests which we did. And this is cool. You can play with these to understand everything. Okay. So let me just close this already so that you can see what happened behind the scene within some few seconds about the code. So if you check what we have here in our code bases as usual, we have our source folder and we have app.module, which is very important because it's where we connect external things to our API. And one of those external things is things like database and cache. So for the .env, as usual, we usually use config module, and then we inject them based on the environment. Other than that import, we have cache module. So this is coming from the cache manager, Nest cache manager. So since it's a nesting, so we can just do cache module dot register sync. So register sync is how we register different things we need to inject to our classes. So one of those things is Redis instance. So we are saying that it's global, so it can be used in different modules. For example, if I go to modules folder, sorry for that, under events in our event module, we don't need to inject it manually because we have already set this to true. So we can use it, by the way, in the events service without actually injecting it inside the event module because this module is global. We shall come back to this in a second. So we're using use factory to create one instance of Redis, okay? This instance is calling config service. So we are injecting config service, which we are typing with our config. If you're confused about config, please watch our previous videos on CRUD. We have a detailed way to set up this. So our config service is aware of everything, all the types we need. Okay, and we are creating a KV store. So we are calling it KV, and then we are passing in the URL so that we can connect to our Redis, and then we are creating a namespace known as event API cache. I think we saw that namespace here, this one, event API cache. So that's a namespace which is even persisted inside our Redis. Other than that, we are calling KV and we are saying on error, throw in error. Other than that, we are returning. Remember, use factory returns an instance of an object. So even if you hook on it, I think you shall see function returning options, promise, resolving, config, cache model. So for our case, we are returning um, an instance of Redis connection, which is stored in an object with all the configurations. Like we have our store, we also have our time to live, which we are fetching from our .env. So this is the global time to live for the whole store. Okay. So if we come to .env, you shall see that we have cache time to live ms, cache time to live ms, which is a minute, and that is because it is 60,000 milliseconds. I've gone ahead to explain that 1 second is 1,000 milliseconds, 1 minute is 60,000 milliseconds, like that. So anything to do with cache, it is stored in milliseconds. Cool. So after this, now we have our Redis ready. We can just use it. So inside our event service, just assume assume those imports for now. They are so big. What is way important is that this is just a class event service, which has different methods, and it also have construct. We have different methods, which are these. These are just private methods at the bottom. We also collapse them. Cool. So we have these public methods with us, which we're going to use to do a CRUD. So how do we bring in Redis? The first thing we need to inject is Drizzle. So Drizzle is our database ORM. We're using this Drizzle namespace. Let me call it namespace, even if it is a constant. If I show you, we're using this symbol to create Drizzle object, and then we are calling all the schemas in our tables, and then typing that inside the node.pg driver to our DrizzleDB object. So, sorry, to our DrizzleDB type. So when we call Drizzle here, we're also calling DrizzleDB type. So here we have Drizzle, the symbol, and then we also have the type. So when we bring in here, we are bringing both of them, the type and the symbol. The symbol, we are going to inject it here, and we are going to give it a variable name known as db, and then type it using our type. So db is aware of the types we have from the schemas. Cool. Then we are going to use cache manager. Where is cache manager coming from? It's coming from cache manager, the library which we installed. Okay. And then cache manager has a type known as cache. Okay. So cache manager, we are making it private read-only, so we can't modify it. And then we're calling it cache manager of type cache. This cache manager is the one we're going to use to do different cache-based methods. So let's say from create. So inside create, we're just bringing in the data from the request, and then here, and then we are typing it using our DTO. We are trying to insert data into our database. Then what we are going to do is we are invalidating all the list caches, because when we insert data, remember the invalidate pattern which we discussed in what the call was starting. When we insert data, when we update data, when we delete data, we are doing things we call mutations. So these are side effects that affect the data which already exists. So it's only fair to delete the cache related to that data which already exists. So by using await this dot bump list version, it's going to do that. What is this bump list we're accessing through this? Every time you have this inside your class, it means you're referring to something inside your class. So when I say this dot bump list version, it means bump list version is a my value. So it is at the bottom, it's one of the private methods. And inside here, all it is doing is it's checking the next version. It's actually getting the version we have and then adding one. So you remember the Redis version pattern, which we had like version 1. And then when we do like an invalidation, which is basically a mutation, like update or insert, um, we have to delete that cache, which was version 1. And then now we have to create a new cache with version 2 now, because it was version 1, increment by 1, we get version 2 and update that cache. So basically, this is what is happening. So it takes the current version, concatenate it, oh, sorry, increment it, and then make it the next version, and then also change the time to live. So this is what we are doing. So here is where now we are doing that and then return the data we inserted. Okay. So let's say we are fetching all the data. So this is where we have a lot of things, because the data can be paginated, it can be sorted, filtered, those type of things. So we have various steps. We have a list where we are storing all the versions. So we have list.get list. So that is a private method at the bottom. Okay, which is this. And basically it is a version-based list invalidation pattern. So basically we are just going to get the current version and see whether we have an error with that, because we can pass a number which is crazy. So we are going to make it a number and make it, is it finite? And then we are waiting the cache manager and setting all the versions we have and then returning this as well. So on top here, where we are getting the list of the versions. So that can be 1, 2, 3, 4, whichever it is. And then we are getting the cache key, okay, which we are going to build from the list version and then the query which you are passing. So if the query is fetch, get, we are going to connect it with the version so that it can be unique. Yep. And then we are going to check whether this data exists. So cache aside read. This checks Redis before querying database. So this is a new pattern now. So we're going to check whether the data exists in our Redis before we fetch it from the database. If it exists, then that is a cache hit. We return the data. If it doesn't exist, what do we do? So if cached, so this is when it exists, we return. If it doesn't exist, so we go ahead to do our normal filter search patterns, which we have for just normal CRUD. And basically what we do is that we fetch from the database, we return that data, and then at the bottom, because now there was no cache for this data, we go ahead to create a cache for the new data that we have fetched. So for find one now, if you're finding one user, or for our case is one event, the same goes. We are trying the cache aside pattern, which first we go to the Redis. If it doesn't exist, well, we'll go to the database. If it exists, return the data. If it doesn't exist, just do the normal select from events where event ID is equals to our ID which we are passing. So about updates. So updates, we are doing the normal updates. So we update first in the database, and then we invalidate the existing cache related to this request. And after that, we update all the cache details, okay, and the BAM list, which is basically deleting all that cache. And then we return the data. If there's an error, we throw it. Okay. For remove, the same goes like the update. We delete the data, and then we do the delete. We delete the cached version of this data, and then we increment our BAM list. So which is basically this is gRPC, which is basically what we explained in the bottom. So these are just normal methods which you're going to use inside the code base. So for example, the time to leave, details time to leave, version time to leave. So these are just private methods which are just doing that, which are basically calling our config services and getting that time. Okay, so that you don't have to come to the code base and edit this, you can just fetch it from the .env directory. So I think I have explained everything about our call today. Any question? Is it confusing? Is it easy to grasp? David, keep on that.
Hi.
Yes, I can hear you.
Yeah. I think it's my first time coming across this, and
Yeah.
I'm liking it though. There are a lot of things running, so I think I'll need more sessions on this to grasp it more.
Okay. Okay. Are you
Yeah,
familiar with the Nest?
not that much.
Okay.
Yeah.
So if you are new to Nest, we have some sessions in the past which we have done even a CRUD application. So in our user group, every event has a link of the recording and the code base. So if you go to here and go to the past, that is Kenya-Data Platform User Group, and go to the past, you shall see we have the API project set up for Nest. This should be your starting point. And then you can go next to CRUD, which will do that. So for example, here, you should see in the comments, uh, you should see a link to the YouTube recording and also the link to GitHub with the code base. So this link to the GitHub with the code base should basically take you to something we are doing in the Node.js backend development list. We have like the first session, the second session. So if you go to like project setup, you should have like a step-by-step explanation on how to do this. This should be easy for you. Okay. So you can watch the video and also you can come to the README to read everything. The same goes to the second project, and even whatever we are discussing today, I'll also upload that to this. So this should be your second one, explaining relationships and how we query data which is related in Nest. and trace on Postgres. So it should help you. Um, yeah. Else you can join also our WhatsApp group, and you should be able to ask any question or ask for any material to help you on something. So, for example, if you do this, so let's say this is a YouTube link. So if I just open this, if you open this, you should be able to go to our YouTube channel where we are uploading these videos, and um, yeah, you can like. Yeah. And these are the videos. We also have a playlist. Let me just show you the playlist. So after today's call, you should see these backend development with Nest, which is a playlist with all the videos. Yep. So yeah, those should help you. You should definitely join our user group. You should be easy to join a user group. And also for our next event, which is next week on Sunday, um, we shall be shifting gears from basically talking about SQL related content, which we have been doing, to a non-SQL type of content. So we have done a lot, caching, CRUD, filtering, all those type of things, which are like the fundamentals concepts in building an API with an SQL database. Next week, we shall be discussing DocumentDB with Nest. So this should be also be beginner friendly. We should be able to create, read, write, and those type of things with Nest and SQL. This database is quite interesting. It's a new database which has um, created by Microsoft and AWS and another group of which have come together to create a collection-based, let me call it document-based database, which is um, which is AI ready, if that makes sense. So it is compatible with MongoDB. So it is 99, I don't know point what, compatible with MongoDB, but it is more than MongoDB. So yeah, so we shall be using this database. It's fully compatible with MongoDB, and we're going to do a lot of things, a lot of cool things like vector search, um, creating things like agents, creating things like RAG systems using these database in future. As I said, it is a database which is an open source database created by Microsoft, AWS, and these other three companies. That is AB and Yugabyte. Yeah, they came up together and created this good database, which I'm happy to create a lot of sessions about. So yeah, I think the call is a little bit lengthy. I think this should be the end of the call. So I've stopped the recording.